Namaste and welcome to DEPED TV, a venue where you can be in one place virtually, even from different locations in reality. This is Teacher Rev, your grade 11 math teacher, your guide to an exciting and amazing math venture. Statistics is a discipline that combines mathematics, economics, research, and practicalities of life. Questions such as who turned out in the poll during candidacy. We do conduct survey to be able to know the preference of different individuals. In this case, we use statistics. The average score of our students in a test is an example of statistics. In a chat group, if we want to know the preference of our classmate regarding certain issue, we ask them to conduct a poll or a survey online via Google Form. This shows how important statistics is in gathering reliable data so that we can come up with a reasonable decision. When we engage to competitions, we either win or lose, but we are not certain of the outcome. Even when we participate in games, again, outcome may be uncertain, but we do know that three situations may happen. We either win, lose, or get even. When we think of chances, we think of probabilities of an event. And when we talk about competitions, games, and opportunities, we have random outcomes. Random because the outcome is uncertain. Today, let's get ready to witness probabilities behind random events as we discover the wonders of random variable. Our life has been a series of chances. Let's talk about chances first. Have you been to an arcade? There will definitely be one period in your life where arcade had been a Sunday bonding with family. What games do you usually see there? If your answers are pinball, coin pusher, claw machine, and several other games, most of the games we see in arcades are chance games. Just like what we mentioned earlier, games that are repeatedly done under similar conditions. Games that we are hooked into hoping that the odds will be in our favor. When we talk about chances, it means we are also dealing with probabilities. In probability, when we do an activity that can be repeatedly done under similar conditions, we are actually doing an experiment. Can you give an example? Things that we do repeatedly. The one that you studied when you were in grade 8, remember? One classic example is tossing a coin. Can you try? Kindly get a coin. Let's try at my count. Ready? And go. What do you think is the result? Let's see if you guessed it right. In this case, the result is a head. The result of a trial in an experiment is called an outcome. Since the experiment of tossing a coin resulted with a head, then head is an outcome. How about you? What result did you get? I'm sure the results vary. If you repeat this activity, is the result always a head? If your answer is no, I agree with you. What other results did you get? I'm sure some got a tail. What about when you spin a coin? What are the possible results? If your answer is a head or tail, then your answer is correct. Note that the result of all possible outcomes in an experiment is called a sample space. And in this case, the sample space is either a head or tail. Let's have another experiment. When we roll a die, what is the sample space? Remember, sample space is the result of all outcomes in an experiment. If your answers are 1, 2, 3, 4, 5, or 6, your answer is correct. Thus, the sample space of rolling a die are 1, 2, 3, 4, 5, and 6, because these are the possible outcomes when rolling a die. Sample space is often used in getting probability of an event. When a coin is tossed, what is the probability of getting a head? If your answer is 1/2, then your answer is correct. For there is 1 out of 2 chances that the result will be a head. Thus, the probability of getting a head is 1/2. What is the probability of getting a number less than 5 in a roll of a die? If your answer is 2/3, your answer is correct. Because there are 4 possible outcomes when we talk about getting a number less than 5. The result can either be 4, 3, 2, or 1. Which means 4 out of 6 can be an outcome, or 2/3. What is the probability of getting a 2 from a standard deck of cards? If your answer is 1/13, your answer is correct. Note that the deck of cards consists of 52 cards, and out of 52 cards, there are 4 cards which contains 2. 2 of hearts, 2 of spades, 2 of diamonds, and 2 of clubs. Then, the probability of getting a 2 is 4 out of 52. Note that fractions are always written in simplest term. Thus, 4 out of 52 will be written as 1/13. When we perform experiments, just like rolling a die, are we certain that the result will be an even number? If your answer is no, I agree with you. Though there is a chance that it might be an even number and a chance that it might not be an even number. These classic experiments that we did, tossing a coin, rolling a die, are chance events. Chance events because outcome is uncertain. A random variable is the result of chance event that you can measure or count. Many parts of our daily experiences in life are random. When we buy drinks at a food stall, how sure are we that we will get the same amount of liquid in our drinks as the others? Definitely, in this situation, there will be a slight difference in terms of the amount of liquid in a medium-sized drink. Again, the result, which is the amount of liquid, would be random. But even though it is random, it doesn't mean we don't have any idea on the capacity of a medium-sized drink. What we do know is that it can go a little beyond 21 ounces of liquid, but it can be a little less than that. See, it may be random, but we have an idea on the capacity the container can hold. Other examples would be the randomness of the result of dice rolled when playing board games. We can also consider the number of combo meals ordered by each customer in every transaction. The individual value of the mentioned random variable are not that predictable, but we can look at the outcome of previous occurrences which will somehow give us a feel, an idea of the behavior of random variables, like tossing a coin 3 times. How? Through recreation or simulation. I remember listening to a profound description of simulation as a means of allowing us to explore the odds that didn't happen, but could have happened. Let's go back to our example on the amount of drinks in a medium-sized container as we delved on simulation to understand more about the randomness of the amount of liquid at a certain fast food store. For instance, your parent invited 500 people in the birthday party of your younger sibling held at a certain fast food store. The store serves a medium-sized drink which has a capacity of 21 ounces. We know that the process of filling each container with liquid is not an exact thing, rather a random process, which signifies that the amount of liquid in a container is a random variable. We don't know exactly how many ounces of liquid will be in each guest drink, but we do know something about the process that generates the amount of liquid. You were curious and started measuring the amount of liquid in each container and found out the amount of liquid in the first container is 19.8 ounces. The second container, 20.25 ounces, followed by 21 ounces and 21.1 ounces, and so on until you measured all. After measuring the amount of liquid on all containers, you created a histogram of the amount of liquid in all the containers to have a better view of the result. It shows that the fast food store is giving the guests a fair amount in terms of the drinks they serve. Most guests receive around 21 ounces of drinks, which is the expected amount. But notice that the randomness of the amount of liquid filling process, based on the graph, it shows that other guests had a little less or a little more than the expected amount. But this happens rarely, though it still happens. So in this case, we expect that the range of values will be somehow 19.8 to 21.1 ounces of liquid in your drink when you order from the said fast food store. Let's have another example. Mang Juan is a milk tea business that sells milk tea of varied flavors, sugar levels, and add-ons. Mang Juan would like to analyze the sale and look at the progress of his business. He wants to do this because he wants to plan the schedule of his employees and see if it is the right time to expand his business. Mang Juan collected data for the past 3 months containing the number of milk tea purchased by each customer who makes transaction. The table shows the number of milk tea purchased by customer per transaction and the number of customers who bought the number of milk tea in a month. If you are a customer who bought 3 orders of milk tea in one transaction, where will you be counted? If your answer is that you're one of the 83 customers, then your answer is correct. How about if you are a customer who bought 5 orders of milk tea in one transaction? Where will you be counted? If your answer is that you're one of the 25 customers, then your answer is correct. In the given table, we can define X as the number of milk tea a customer orders per transaction, and X is a random variable. X is random because it can take several different values, which is a result of chance happening. Note that the variable we are referring to here is a different variable we used to know in algebra, though it has the same characteristic of taking on values. Remember, X is defined as the number of milk tea a customer orders per transaction. In this case, a person would have made 1 order of milk tea, 2 orders of milk tea, 3 orders of milk tea, and so on until 5 orders of milk tea. Thus, the possible values of the random variable X are 1, 2, 3, 4, and 5, which is also the mass points of random variable X. Based on the explanation, what is a random variable X? A random variable is a variable whose values depend on an outcome of an experiment. A random variable is denoted by an uppercase letter, and its possible values are denoted by a lowercase letter. Another example of random variable is the number of heads acquired when a coin is tossed twice. Let's represent getting a head as H and getting a tail as T. Note that the random variable X is the number of heads when a coin is tossed twice. Do you want to try this activity? Kindly get a coin and let's try this activity. I got head on the first trial and a tail on the second trial. Since it is a chance event, our outcomes may or may not be the same. What did you get? Did you get 2 tails? A head followed by a tail just like mine? A tail followed by a head? or 2 heads? Is the result of your trial in our list? For sure it is in our list because the items represents the sample space. Since x is a random variable of getting a head, let's count the number of heads in each outcome. For the first outcome in our list, there is no head with the outcome of 2 tails. Remember, it has to be numerical, so what are we going to write? We are going to write 0. For the second and third outcome in our list, we have 1 head in each outcome. So, we're going to write 1. And for the last item, we have 2 heads. So, we're going to write 2. So, what are the possible values of random variable x? If your answer is that the possible values of the random variable x are 0, 1, and 2, your answer is correct. It means that the outcome of a trial may have no head, 1 head, or 2 heads. Let's expand our understanding of our data and create a table. Let us fill the number of heads in descending value of x. Can you fill up the first row? If you placed 2, 1, and 0 in proper order, then your answer is correct. The sample points are the outcomes with a designated number of heads. Where will we place 2 heads? Tail followed by head, head followed by tail, and 2 tails. Let's see. 2 heads, head followed by tail, tail followed by head, and 2 tails. Let's see. Did you get the proper placement? That's good. The number of occurrence refer to the number of items in each sample points. Can you fill up the third row? If you placed 1, 2, 1, then your answer is correct. Note that there is only 1 outcome with the result of 2 heads. Also, there are 2 outcomes in the sample space that resulted with 1 head. Lastly, there is only 1 outcome with the result of both tails, meaning no head. This time, let's get the probability by getting the ratio of the number of occurrence in each column to the total number of items in the sample space. Can you fill up the fourth row? Since there are 4 items in the sample space, then the probabilities are 1/4, 1/2, 1/4, in that order. If this set is your answer, then your answer is correct. So what really is random variable? A random variable is the capacity that connects a real number with every component in the sample space. It is a variable whose qualities are controlled by chance. In this manner, a random variable is a numerical amount that is derived from the results of an arbitrary trial or experiment. That is random variable. Let's look at the following situations and determine whether the situations calls for random variable. I'll give you 5 seconds to answer after I read each item. Number 1. The gender of the people who enter the library. If your answer is not a random variable, then you're correct, because we are merely identifying their gender. But if we talk about the number of female, then that becomes a random variable. Second item, the number of books a person have. If your answer is a random variable, then you're correct, because we'll be able to connect real number to sample space when the focus is on number of items. Let's go to the third item, the number of tellers busy at 1 p.m. Is it random variable or not? If your answer is a random variable, then you're correct. Let's go to the fourth item, the method that the customer used to pay. If your answer is not a random variable, then you're correct, because we are merely identifying method of payment. Let's go to the fifth item, the number of customers who pay by cash. If your answer is a random variable, then you're correct. How did you do with our activity? Hope you aced it, and I hope now you understand random variable very well. Our study of random variable will not stop by understanding what random variable is. This time, let us focus on the types of random variable. There are two types of random variable, discrete or continuous. Let's focus on discrete random variable first. Let's go back to Mang Juan's situation. The number of milk tea sold per transaction is an example of discrete random variable. Since we can only get a whole number of milk tea, not half nor 1/4, but whole. This means that discrete random variable is a variable which can only view a countable amount of values. From our example of tossing a coin, the random variable of getting ahead from our previous activity is an example of discrete random variable. So what is discrete random variable? Discrete random variable is a variable that can take on finite number of distinct values. When we say finite, it is something that is countable. Distinct values mean different values. Let's discuss some examples of discrete random variables from Mang Juan's situation. The number of customers who use cashless payment is discrete random variable because we can only get a whole number value for a random variable x, which is the number of customers. Of course, we cannot have a half for the number of customer. Even if a child is buying, the child cannot be counted as half, rather as one customer. Another example of discrete random variable is the number of days in a month where the store is closed due to pandemic situation. This is also discrete random variable because we can only get a whole number value for random variable x, which is the number of days. So let's recall. We identified from earlier discussion that the following examples are discrete random variable. The number of milk tea sold per transaction where x can be 1, 2, 3, 4, or 5, meaning a customer purchased 1 order of milk tea, 2 orders of milk tea, and so on up to 5 orders of milk tea in one transaction. Second, the number of heads when a coin is tossed twice, where x can be 0, 1, 2, meaning when a coin is flipped, outcomes can have 0 heads, 1 head, or 2 heads. Third, the number of customers who use cashless payment. 4. The number of days in a month where the store is closed due to pandemic. All these are countable values, and all these are examples of discrete random variables. Remember, random variables can either be discrete or continuous. Hope everything is clear with discrete random variables. This time, let's talk about continuous random variable. Continuous random variable can take any values within a range including fractions and decimal. Let's go back to Mang Juan's situation. If we want to get the amount of liquid in an order of milk tea, it would take a range of values in milliliters. This is an example of continuous random variable. If we are interested to know how long is it to create an order of milk tea or how long will a customer wait for the order, both are continuous random variable. Other examples of continuous random variables are the height of a grade 11 student or the room temperature. So what really is continuous random variables? Continuous random variable are random variables that take interminably uncountable number of potential values, regularly measurable amounts. So let's recall. We identified the following example of continuous variables. First, the amount of liquid in an order of milk tea. Second, the time to create an order of milk tea. Third, the height of a grade 11 student. Fourth, the room temperature. All these are measurable amounts, and all of these are examples of continuous random variable. Let's summarize what we know about discrete and continuous variables. This means that discrete random variable is a variable which can only view a countable amount of values. Continuous random variable can take any values within a range including fractions and decimals, regularly measurable amounts. This time, let's see if you'll be able to identify whether a random variable is discrete or continuous. I'll give you 5 seconds to come up with an answer. So, are we good? Ready? Let's have our first item. The weight of a school bag. Is it discrete or continuous? If your answer is continuous, then your answer is correct. Weight is a measurable amount. Next item, ready. Item number 2. Number of emergency calls in an hour from a COVID-19 hotline. If your answer is discrete, then your answer is correct. Number of calls is a countable amount. Let's go for our third item, recording the distance traveled by the bus. Is it discrete or continuous? If your answer is continuous, then your answer is correct. Distance is a measurable amount. Let's go to our fourth item, surveying about the number of cases due to COVID-19 pandemic in certain locality. If your answer is discrete, then your answer is correct. The number of cases is a countable amount. Item number 5. The number of promoted students at the end of the school year. Is it discrete or continuous? If your answer is discrete, then your answer is correct. The number of promoted students is a countable amount. Hope you did well with our activity. Do I hear a 5? That's good. It means you understand random variable very well. Let's go back to Mang Juan's situation. We estimate the probability for each value of x by finding the relevant frequencies from the experimental data. The distribution of x, the number of milk tea a customer buys, looks like this. The set of all possible value of the random variable x, together with their corresponding associate probabilities, form the probability distribution of x. And if x is a discrete random variable, the probability distribution is called the probability mass function, or PMF. As a dot diagram, the probability mass function, or PMF, looks like this, which could be arranged to form histogram that looks like this. Remember, the random variable x, which is the number of milk tea a customer buys, is a discrete random variable, which can be presented as a distribution in tabular form and in graphical form. This can be used to answer questions such as, What is the probability that the next customer will buy exactly 2 milk tea? We'll look at the table and the graph and say that the probability that x is equal to 2 is 0.29 or 29%. Thus, there is 29% chance that the next customer will buy 2 milk tea. This means that a discrete random variable distribution can be presented in tabular or graphical form. This time, let us recall what we discussed today. A random variable is a numerical quantity that is derived from the outcomes of a random experiment. A discrete random variable is a random variable whose values are represented by count data. This happens when the set of possible outcomes from an experiment can be counted. A continuous random variable is a random variable that takes values on a continuous scale. This happens when the set of possible outcomes from an experiment cannot be counted but can be measured. A discrete random variable distribution can be presented in tabular form or graphical form. Probability distribution of x is the set of all possible values of the random variable x together with their corresponding associated probabilities. And if x is a discrete random variable, the probability distribution is called the probability mass function or PMF. Today had been a great learning experience. So, see you next week on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!